Welcome again. This is the second lecture in the mathematics. In the previous lecture, we discussed about the basic concept of the derivative, and we see that the governing equation of the derivative can be summarized in seventh rule. Let me make a quick review about what we learned in the previous lecture. We say that d by dx for c, where c is any constant, will be 0. For example, d by dx of 10, for example, will be 0. Also, we learned that d by dx for u, where u is any function, for example, d by dx for u to the power 3, we learn that d by dx u to the power n is equal to n multiplied by u to the power n minus 1 multiplied by du by dx. So that we can apply this law to this function, which is u to the power 3, where the power n is 3 here, so that it can be solved like this. This will be n here, so that here will be 3 multiplied by u to the power n minus 1, and since n here is 3, so that this will be 3 minus 1 multiplied by the derivative of this function u, which is du by dx. And in this way we can write it like this, 3 u squared multiplied by du by dx. However, in the next section we will elaborate and take a lot of complex example. For example, u may be sine, cosine, maybe this trigonometric function or any other function, so that its derivative will be more complicated. Besides that, we take also that derivative of u d by dx u multiplied by v, which is this is derivative of product function, can be solved like this. The first function here, which is u, and this is the second function, so that I can write the derivative for u multiplied by v like this. The first function u multiplied by the derivative of the second function, which is dv by dx, plus the second function, which is v multiplied by the derivative of the first function, which is du by dx. Finally, we take d by dx for u divided by v, which is function divided by another function. It can be solved like this. In the denominator we have v, so that it will be v squared, and in the numerator we have the denominator, which is v, multiplied by the derivative of the denominator, which is du by dx, minus u, which is the numerator, multiplied by derivative of denominator, which is dv by dx. And we take a lot of examples that cover this topic. Also, we explain the concept of chain rule, and also we take the derivative of higher function. For example, derivative of if y equal to x to the power 3, then dy by dx will be 3x squared multiplied by the derivative of x with respect to x will be 1, and the second derivative d square y dx square can be written like this, 3 multiplied by 2x to the power 1, so that it will be 6x. And also we find the third derivative, which is d to the power 3y divided by x to the power 3, and for this is x. Finally, the derivative of the fourth derivative, d to the power 4 divided by dx to the power 4 will be 0, because 6 here is a constant, and we say that the derivative of constant is 0. Also, we illustrate the implicit differentiation and take example cover the implicit differentiation. However, let us take another function. For example, if we are interested in finding the derivative of the logarithmic function, for example, d by dx for a to the power u, d by dx for a to the power u. This can be differentiated like this: a to the power u multiply by ln a dot du by dx. And also the derivative of the exponential function, which is d by dx for exponential to the power u, will be e to the power u, which means that we write the function as it is given, so that d by dx for u to the power u, e to the power u will be e to the power u multiplied by du by dx. And this is actually this lecture focus on explaining how can we derive the derivative of exponential function and logarithmic function. So that as a beginning, let us illustrate the exponential function. And how can we find the derivative? Okay, so that the goal of the present lecture is how to find the derivative of the exponential function. For the exponential function, we have only these two equation, which is d by dx for a to the power u is a to the power u multiplied by ln a du by dx, and d by dx for e to the power u will be exponential a u du by dx. Let us take example, illustrate this law. For example, let us find the dy by dx for the following function. Let us take the first function, which is find dy by dx for the following function. The first function will be y equal 2 to the power 3x. This is the first function. So that this is actually can be solved, which is d by dx for a to the power u equal to a to the power u ln a du by dx. Let us apply this law to this function, so that here we have dy by dx. We will find the derivative of this function, dy over dx. Here 2 to the power 3x, and we can see that a is equal to 2, so that here I can write a to the power a, which is 2 to the power 3x, okay, multiplied by ln a, and a here is the number, which is 2, multiplied by the derivative of u, and u here is 3x, so that the derivative of 3x, let us write it d by dx for 3x. We can write it as 2 to the power 3x ln 2 multiplied by 3, because the derivative of dx is 3. We can rearrange it like this: 2 to the power 3x multiplied by 3 multiplied by ln 2. This is the derivative of y equal to 2 to the power 3x, which is 2 to the power 3x multiplied by 3 multiplied by ln 2. Now let us take another example about this topic. For example, if y equal to 2x to the power 2. The same approach can be used here. Here we have a to the power u. We want to find the derivative of a to the power u. We know that this can be written like this: 2 to the power 2x. In this way, we can find that y equal to 2 to the power 2x. so that we are interested in finding the derivative of a to the power u. We can make a comparison. For example, we have the law which is d by dx for a to the power u is equal to a to the power u ln a multiplied by du by dx, so that we can apply this rule to this function in order to find d by dx to 2 to the power 2x will be, here we find that a is 2 and u is 2x, so that a to the power u, the solution of this derivative is a to the power u, which is 2 to the power 2x multiplied by ln a, and a here is 2, so that I can write it 2 dot du to the by dx. We know that u, we can make a comparison, a to the power u, which is a to the power u. We can see that a is 2 and u is equal to 2x, so that u equal to x, then du by dx will be 2. Okay, so that I can write here 2. In this way, we find that d by dx for 2 to the power 2x equal to 2x dot ln 2 multiplied by 2. Now we can make a lot of more simplification. For example, this is 2 and this is 2, so that I can write it 2 to the power 2x plus 1 multiplied by ln 2. So that it can be seen that if we apply the rule that governing the derivative of a to the power u, it can be seen easily we can find a to the power u derivative. Let us take another example about the exponential function. For example, y equal to exponential, let us take square root of 1 plus 5 x to the power 2. Actually, first let us write the law of derivative of exponential function, which is d by dx for e to the power u is equal to e to the power u dot du by dx. Now let us explain the following. We know that this is e, and the function u is nothing but u equal to square root of 1 plus 5 x squared. We can write the square root function like this: 1 plus 5 x squared to the power 1 over 2. Now, in order to find the derivative of exponential u for this function, we first need du by dx. We know that exponential u, that u, this is u, so that we require to find du by dx. Actually, we can see that y, the example given for us is y equal to exponential 1 plus 5 x squared, so that we can write that dy by dx equal to exponential 1 plus 5 x squared multiplied by, this is u as we mentioned, du by dx, and so that I can write d by dx for square root 1 plus 5 x squared. Now we can separate this term separately. For example, u equal to 1 plus 5 x squared to the power 1 over 2. Then du by dx will be, this is nothing but u to the power n, so that d by dx for u to the power n is nothing but n u n minus 1 du by dx. In this way we can write that du by dx is 1 over 2, 1 plus 5 x squared, 1 over 2 minus 1 is minus 1 over 2 multiplied by the derivative of inside the bracket, which is 1 plus 5 x squared, so that it can be differentiated easily, which is when the derivative of constant is 0, so that and derivative of 5x squared is equal to 2 multiplied by 5x to the power 2, so that it will be 10x. Now we can do the following simplification. For example, this 2 can be cancelled with this, so that we have 5x divided by 1 plus 5x squared to the power minus 1 over 2 will be transferred to the denominator, and then we transfer it to the square root, so that I can write it 1 plus 5x squared under the root. This is du over dx, okay, which is this, so that dy by dx for exponential u, and u here is 1 plus 5x squared, it can be written like this, as mentioned for us, y equal to exponential 1 plus 5x squared. In this way we can find that dy by dx equal to exponential 1 plus 5x squared multiplied by this, which is the derivative of this, which is 5x divided by 1 plus 5x squared. So that in this way we explain how can we find the derivative of a to the power u, and a, as I mentioned before, is any number, or find the derivative of exponential function, which is e to the power u. And we illustrate this derivative in full details. Now let us take another functions. For example, or let us take, after we complete the derivative of the exponential function, let us transfer to the derivative of the logarithmic function. For example, d by dx for log a u, this is the, its function will be 1 over u ln a multiplied by du by dx. And also if we want to find d by dx for ln u, this will be 1 over u du over dx. So that for the logarithmic function, if u is actually any differentiable function of x, then d by dx for this function will be something like this, and d by dx for ln u is nothing but 1 over u du by dx. So that if we know, or if we say the rule, then it is very simple to find the derivative of a function like this. So that let us take example, illustrate this topic. For example, if y equal to log 10 for e to the power x. Now, actually this function, we can see here that log, if we make a comparison between this function and this function, we can see that a here is 10 and u is exponential x, so that all I have to do to find the derivative of this function is to find a and u, and how can I derive them, so that I can write it that dy by dx equal to, let me show you, dy by dx for log a to 10 to exponential x now will be 1 over u, and u here is actually exponential x multiplied by ln a, and a here is 10, multiplied by du by dx, okay, which is here, this du by dx, so that you can see that actually u is exponential x, so that if I sorry, if I want to find du by dx, then as I mentioned before, just before a few minutes, that exponential function, if I want to find its derivative, all I have to do is to write it as it is given for me, which is exponential x multiplied by the derivative of function, which is here x, so that derivative of x with respect to x is 1, so that I have exponential x. In this way I can write it like this, exponential, sorry, x is here, x to the power x, e to the power x divided by exponential x then 10. Now of course this can be cancelled with this, actually exponential x can be cancelled from the denominator and numerator, so that I have 1 over ln 10. Now let us take another example that cover the derivative of ln. For example, if I want to find for example y equal to, let us take example about ln, y equal ln, let us take it ln, y equal ln x squared plus 2 to square to the power 3. So that actually in the derivative subject, all we have to do is that we should apply the rules that we take it in the first lecture, so that this is actually nothing but function to the power, which is u equal u to the power n, so that if I want to find the derivative of function to the power, then I apply this rule, which is dy by with respect to u here will be n multiplied by u n minus 1 multiplied by the derivative of u, okay, so that I can write it here du, so that this rule can be applied here. This is function y, so that dy by dx will be 3 as, which is here n, 3 multiplied by the function, which is ln x squared plus 2 square to the power 3 minus 1, 2 n minus 1, so that 3 minus 1 is 2 multiplied by the derivative of u, okay, derivative of u. Now the derivative of ln, we have the law d by dx for ln u, okay. If I want to find the derivative of the natural logarithm, so that it will be like this, 1 over u multiplied by du by dx. In this way I can differentiate it like this. I want to find the derivative of this only, so that this will be like this, 1 over x squared plus 2 to the power 2 multiplied by the derivative of du by dx, the derivative of this function. We know that this is again a function multiplied to the power, so that I will apply the the same rule, so that this will be here multiplied by 2, this will be 2 this will be 2 multiplied by x squared plus 2 to the power 1 multiplied by the derivative of inside the bracket, which is 2x. Okay, now after that I can do the following simplification. For example, I can write that dy by dx equal to, after I cancel this x squared plus 2, when this is x squared plus 2, but this is to the power, so that this will be cancelled, and this will be only x squared to the plus 2 to the power 1, and this 2 can be multiplied by this, which is 2 multiplied by 2 is 4, multiplied by 3, so that I have 12x ln x squared plus 2 squared divided by x squared plus 2 only, because it is cancelled with this, so that I have only to the power 1. So that in this lecture we illustrate how can we find the derivative of the natural logarithm and the exponential function, so that actually if we know the governing equation or the rule that apply to find the derivative of the exponential and logarithmic function, then it will be very easy to find its derivative. So that in these two lectures, lecture 1 and lecture 2, we can find the derivative of a simple function. For example, we find the derivative of x squared, and also we go in full details about the derivative of more complicated function, which is natural logarithm function and exponential function, and we complete them. However, in the subject of the derivative, we have a rule that we should focus on them, which is the rule of d by dx for u plus v, or u multiplied by v, or u divided by v, or u to the power n, and we apply them to various functions. So that in the first lecture we consider the function of general function, for example x squared plus x plus 1, and we take how can we find the derivative of exponential function or logarithmic function. However, in the next lecture we will illustrate how can we find the derivative of the trigonometric functions, and this will be more complicated because here we need to know a lot of equation and a lot of formula for the trigonometric functions. This subject will be illustrated in the next lecture, which is about the derivative of trigonometric function in full details. Thank you very much.